What if the outer edge of our solar system isn't empty, but hiding a ninth planet? Could it be a frozen object up to 10 times the mass of Earth, silently bending the orbits of distant objects in complete darkness? Or something even worse, an ancient black hole drifting through the void, the size of a grapefruit. We thought we knew our solar system. Then Pluto was demoted to a dwarf planet. Now, something doesn't add up. Fasten your seatbelt. We are going into the dark to find it. Tug of war. Scientists at Caltech ran the simulations. They looked at 29 specific objects crossing Neptune's orbit. I could hit you with all the technobabble about orbital alignments, but here is the bottom line. The chance of these orbits happening randomly without a Planet 9 has been rejected at 5 sigma. 5 sigma means there's a 1 in 3.5 million chance this is a fluke. Never tell me the odds. The math practically screams that it is out there. So, case closed, right? We've solved the mystery. Just kidding. We still have a long way to go. Proving it with math is one thing, seeing it is another. If we know it is there, why do we not just point a massive telescope at the sky and take a picture? Because space is dark. To see it in visible light, sunlight has to travel 600 AU, bounce off the planet, and travel all the way back. By the time that light returns, it would be 160,000 times dimmer than Neptune. You literally have a better chance of spotting a specific speck of dust blowing across a football field in the middle of a hurricane at midnight. But what if we stop looking for light and start looking for heat? A planet's thermal radiation only has to make a one-way trip, making it about 100 times brighter in infrared. Researchers combed through old satellite data and found a tiny dot that moved over 23 years. Frankly, they might have just found it. So, what happens if we actually build a ship, fly out there, and see it for ourselves? Let's run the first simulation. You hop in a ship and travel to the absolute outer limits. You land, open the airlock, and expect to step out and gracefully float around like Neil Armstrong on the moon. Nope. You immediately faceplant into the dirt. Hard. Oh God. Ouch. Welcome to candidate number 1. This version of Planet 9 is a massive rocky super-Earth, up to 10 times more massive than our planet. Imagine taking Australia, multiplying it by 50, and freezing it solid. It's a harsh, unforgiving world of frozen nitrogen oceans and jagged mountains of solid water ice that completely dwarf our tallest skyscrapers. Imagine standing at the bottom of a frozen valley that makes the Grand Canyon look like a tiny crack in your driveway. As you try to stand up from your embarrassing faceplant, you notice a slight problem. You can't. The gravity here is so intensely punishing that your body suddenly feels like it weighs 800 pounds. Walking on this surface would feel like wearing a heavy lead suit while carrying a backpack chock full of solid gold bricks. Your quads are burning. Your glutes are straining just to keep your knees from snapping backward. You might think, hey, I have been hitting the gym. I got this. No, you don't. Biology does not care about your deadlift max. Your spine physically compresses. Your heart simply cannot pump blood to your brain against the extreme downward pull of this supergravity. You pass out and die in a jiff. But let's say you have an exosuit. You look out over the pitch-black horizon and see an active volcano. Awesome, right? At least there is some heat. Except it is not spewing hot lava. The core of this massive planet is churning, driving violent cryovolcanoes. These eruptions shoot massive plumes of liquid nitrogen straight into the freezing void of space. It is basically the universe's most aggressive air conditioning unit. Think you could handle it? Yeah, me neither. Let's get out of here. Okay, scratch the super Earth. That was a terrible idea. Let's look at candidate number 2. What if Planet 9 is actually a mini-Neptune? Picture a rejected ice giant violently slingshotted out of the inner solar system 4 billion years ago by Jupiter and Saturn. You cannot land on this one. There is no solid ground to faceplant onto. Underneath a ridiculously deep, swirling atmosphere of hydrogen and helium, there is a slushy, high-pressure mantle of water, ammonia, and methane ice. To put it in perspective, because of all that trapped ammonia gas, it smells like farts down there anyway. Pure stink. You drop from your ship and begin your descent. As you fall through the thick clouds, the pressure builds up instantly, squeezing your capsule from all sides. The temperature drops to minus 350 degrees Fahrenheit. The cold out here is severe enough to shatter cheap metal. You decide to push the panic button. And to add insult to injury, it starts raining, but not water. Oh no. The extreme atmospheric pressure acts like a giant cosmic vice grip. It literally crushes the methane gas into pure carbon. It is literally raining diamonds. Millions of jagged, bullet-fast diamonds. They are plummeting through the heavy atmosphere at terminal velocity and shredding your ship to pieces like cosmic buckshot. The alarms are screaming, getting destroyed by a storm of jewels. Am I right? There are worse ways to go. At least you are going out covered in bling. Well, I have some bad news. There is a third option. What if the reason we cannot find this massive planet is because it isn't a planet at all? Enter the trifecta of doom. The ultimate rug pull. Some physicists strongly believe the object messing with our solar system, the invisible magnet pulling on all those space rocks, is actually a tiny ancient black hole. Now, before you picture a giant swirling vortex swallowing the sun, let's scale it back. This is a primordial black hole formed in the chaotic seconds right after the Big Bang. It has the crushing mass of 10 Earths, but its event horizon is compressed down to the size of a grapefruit, or a softball. Imagine that. A black hole the size of a piece of fruit, sitting smack dab in the middle of the Kuiper Belt, silently warping the gravity of billions of miles of space. It is just hanging out there, invisible, heavy, utterly terrifying. You could be floating right next to it in your spaceship and never see it until it quietly tore your atoms apart. How do you find a pitch-black grapefruit in a pitch-black universe? You don't look for the hole, you cannot see it. You look for the sudden brief flares of passing comets getting violently gobbled up as they fly too close. Whoa. The gravity stretches the comet. The friction heats it to incredible temperatures. It flashes brilliantly in the pitch-black void, and then nothing. Silence. So, what are we dealing with? Is it a frozen super-Earth with crushing gravity? A diamond-raining gas giant that got kicked out of the planetary family? Or a grapefruit of absolute destruction? The truth is headed our way. Right now, high up in the mountains of Chile, the Vera C. Rubin Observatory is preparing to ramp up operations. It has the biggest digital camera ever built. We are talking about a lens so incredibly sensitive, it could spot a single lit candle on the surface of the moon. It is taking a 10-year time-lapse of the entire sky. It is scanning the darkness faster and deeper than anything we have ever built. Within the next year or two, we will finally know for a fact if Planet 9 exists. The shadows have nowhere left to hide. And if we find it, what do we name it? Let's face it, we are out of good Roman gods. All the spiffy names are taken. There is actually a massive internet petition to name it David Bowie. I don't know about you, but a rogue ice giant named David Bowie lurking in the dark sounds pretty rock and roll. If your brain is hurting in a good way, hit that like button and make sure you are subscribed. Stay curious, Space Cowboys. The universe has laws, but we're here to push them to the breaking point. Until then, catch you on the next one.